Good evening, Dave.
Good evening, Mike. How are you tonight?
I am living the dream, as I like to tell many of my customers. I'm sure that's a phrase you're quite familiar with.
Oh, of course, of course. We're all living the dream this past year and a half.
Well, obviously, Dave and I want to thank everybody for joining us tonight for this webinar. We appreciate everybody taking the time to spend about an hour with us to talk about the wireless future of smart pumps and smart controls. My name is Michael. I'm the Technical Services Manager at Eat Energy Equipment. I've been here for 20 years. Previous to that, I worked in the field and got my hands dirty. I'm actually standing in the hydronics lab at Eaton Energy. So there's a whole bunch of products installed behind me and actually in front of me. So obviously lots of Taco product. We're big fans of the Taco product. There's IVC product installed here, and there's some wireless controls that we're also going to talk about. Dave, introduce yourself to the people who may not know who you are, but I think that's a small list.
Oh, I'm sure many people haven't met me yet. So I am, my name's Dave Holdorf. I am the East Coast regional trainer for Taco. And what I mean by East Coast is half of North America is what I cover. I live on the East Coast, but I cover the entire half of North America, and we have another guy on the West Coast that does the other half. So for the last year and a half, though, of course, doing online here. So I've been with Taco now for over 9 years as a trainer in that position, and before that, I was with Uponor as a field tech / inside design / tech support / General Joe / jeans and boots guy. Did that for about 15 years doing that side of things, and then and before that, yeah, I got my hands dirty, but I was a machinist, so didn't grow up in the trades, but I I learned it really quickly, and now I do spend more time doing training than anything, obviously, and trade shows and whatnot. So Mike, thanks for inviting me, thanks for having us, and of course, again, thanks to everybody coming and joining us tonight to see what we have to talk about. It's gonna be a great presentation. I'm excited for it. We have also donated to Mike a couple of 0018E circulators that we're going to give away. And the way that we're going to give those away tonight, all right, well, we're not going to give them away tonight. We're going to give them away tomorrow, all right, because it's just a little hard to manage it between everybody that's showing up and all the names that are popping in there now. But the way to win is to participate in the conversation with Mike and I. And how do you participate in the conversation? Because you don't have a camera and you don't have a microphone like we do, is by the question and chat area there. All right, so if you guys take a look and make sure that you can see and use the chat or question area, you should see the control panel. If the arrow, the orange arrow, is pointing to the left, what I want you to do is click on that. It'll expand it out, and you should be able to find the question section. And just to make sure, type something in there. Type in a hi, hello, how are you? Just so we know that you guys can communicate with us there. And I see Roger and Dale has jumped in there already, and Eric is in there. And this way we know that the equipment is also working on our side. Mike and I have been doing a lot of webinars, and when it dies on our end, we don't know. So we like to ask and see the conversations pop up. So Tim and Casper and Jordan, excellent. Everything is working. Cam and George, glad to see it, that you guys are working. So what we're going to do tomorrow is, when you participate like this, those are instant ballots into winning something tomorrow. All right. So the more times you are conversing with us in here, the more time, then we'll be able to pull the names out of the hat, so to speak, tomorrow, and Mike will email you about those 0018 circs. So awesome. Thanks very much.
So sort of as you have questions, bring them up. Dave and I, we've got a PowerPoint presentation. The reality is we both know what we're talking about. The PowerPoint's to make sure we don't miss something. So as you have questions, throw them out. Dave is going to monitor the questions for me so that as they come up, he'll bring them out and we'll certainly address them. There's no question that's off topic. As long as it sort of falls into what we're talking about, then we're good to go. And with that note, we're going to move on a little bit. So tonight we're going to be discussing two unique hydronic projects. The goal of these projects is to specifically talk about wireless controls. So we're going to talk about cool things like power meters, remote temperature sensors, wireless thermostats, radiator valves, etc. And then also as part of that, we're going to talk about some of the Taco smart pumps, as Dave and I would call them, that sort of complete the mechanical solution. So some of these you'll be familiar with, some of them you won't. The 0018E, the 0015, 0026, and the VT. And we're going to run through all of the different products and how they're going to fit into these two unique hydronic projects that we're looking at. So starting off, Dave, just walk us quickly through the products that we're going to be talking about from Taco.
All right, so we've been working with the ECM circulator line tonight with the designs that Mike has put together, and we talked about what circulator to use where and why, and we'll go through that tonight. So this is the focus of our ECM line right now, and definitely not the end of it either. So we start off, and if you look at the third pump in from the right from the left side is going to be the 0015E3 ECM circulator. Residential size, so to speak, the 0018E circulator, the VT2218. Those three circulators are going to be our major ECM residential size circulators. And then every once in a while, you might run into a need to go into the 26E circulator, a little bit larger of a circulator. And I'm going to talk about each detail today, but these are all our high efficiency ECM circs that we're going to talk about today. Not that the standard AC is gone, all right? But these are, if you haven't used one yet, I highly suggest to start using them soon. Get familiar with them. They are easy replacements to what you're doing today. And we'll talk about those reasons as we go through tonight.
Yeah, the other nice draw with the, especially the 0015, 0018, is that in previous years, the cost was what's driving a lot of contractors to go with a more standard non-ECM circulator. The reality is you can buy a 0015 pump now for a really reasonable price. As you can kind of see from where I'm standing, I'm leaning on a 0015, so this entire table has a prefabbed design, and on the wall behind me we have basically every version of Taco's pumps. We use them in just about every design that we provide for our contractors or our engineering partners. As far as the wireless controls that we're going to be talking about tonight, so we're going to be talking about a new wireless control. And the advantage to this control really is the fact that it is, as we say, wireless. There are no wires involved in the process. It's a very simple plug and play system. The real key thing here is it's not a Wi-Fi control. A lot of smart controls require the contractor to go to the homeowner and say, hey, where's your router? What's your Wi-Fi credentials? How do I get connected? We're not faced with anything like that in this sort of a scenario. The other nice thing about these particular wireless controls is they're compatible with any boiler that's on the market now. So whether it's a standard boiler that takes a TT call, or whether it's a boiler where we're going to take full read-write modulation of it, there is a lot of options that are out there as part of smart controls. The other nice part about this particular one that we're talking about is it's similar to your Tesla. Those of you who have a Tesla, most of us are familiar with them. Dave and I don't drive Teslas, but it accepts over-the-air updates. So as product gets updated and changes are made and features are added, you're not out there swapping products out. They're simply getting updated in real time as updates are pushed out to them. Obviously, it has full approvals for North America and Canada. And just as a small disclaimer, the wireless controls have no affiliation with Taco. We just happen to be, we're going to spend some time together and cover a couple of different topics here. So right off the bat, project one, in this first project, we're using what's called a VX boiler. So this VX boiler is the latest condensing boiler that IBC has released. It's a really cool boiler. For those of you familiar with the IBC boilers, just think SL boiler in a slightly smaller footprint with very similar features, very similar control at a much more attractive price point. So has the ability to actually control 5 pumps and 4 loads packaged out of that unit. It has a really cool online contractor portal so that you can go online, you can see the system, you can troubleshoot the system. Best of all, when you call my team and say, hey, we've got this boiler giving us some grief, we can log into it, we can look at it, we can see what's going on. In this particular mechanical, we're going to include 3 loads of Rayhow in-floor. We're going to have a smart air handler on it, which we're going to talk about, and obviously a standard 40-gallon domestic hot water indirect. So this is the mechanical we've drawn up. We're not going to spend too much time talking about the actual mechanical drawing, but it's a pretty simple setup. So we've got as we say, a VX boiler where we have indirect domestic hot water that opts out. So this particular boiler is smart enough that when the domestic comes on, it'll opt it out. It'll put all its energy into that domestic tank to get it up to temperature. We're using a low loss header in this design. So this is a low loss header that has integrated air and dirt inside of it. And then obviously on the secondary side, we're using the classic short fat headers. We're sizing our piping so that it's under 2 feet per second. It's very simple, KISS method for piping, where we don't have to worry about the pumps that Dave is going to select competing with each other if one is bigger than the other. So it's a very simple, easy mechanical setup. The thing that we really like about the boiler that's been selected in this one really is the KISS method, which is what we've been talking about. Anybody without a manual, without directions from me, can set this boiler up and have all the loads running in under 10 minutes. And added to that, IBC's put a lot of time into a contractor portal where contractors can go in, they can see their equipment, and anything that you can see on site, you can see remotely, and even I can see remotely, which means you're providing a better level of service to your customer, and in turn, we can provide a better level of service to our contractor partners who are using this product. So really, again, as we talk about smart controls, it's not just all about the smart pump. There's also external smart controls, but you want to make sure you're picking a boiler partner as well that has the integrated brains that you want as part of the system. So as far as the wireless controls go, the way that this wireless system works is quite simple. There is a gateway. So this gateway that connects to the boiler is a very simple 2-wire connection. It's a non-polarity sensitive. And as soon as you hook the 2-wire from this gateway to your boiler, in this case, the IBC VX boiler, you have now given that boiler basically a completely wireless zoning system, which Dave and I are going to run through. How this works is you'll actually take your phone and you will connect directly to the gateway. There's no requirement for Wi-Fi. And even if the homeowner doesn't have Wi-Fi, it doesn't matter. The entire system lives on the gateway in the actual homeowner's home or the commercial building. There is no external connection required. If the homeowner wants Wi-Fi, they can log in, they can put their Wi-Fi credentials in, pardon me. There is an Ethernet port on the bottom. If they want to plug Ethernet in, they can. As most of us know as we're talking, there's not a lot of mechanical rooms that have Ethernet, which is why there is also a Wi-Fi radio integrated should the homeowner want to internet enable it. Moving on from the boiler, so now that the boiler is set up, we have the wireless gateway hooked up, very simple 2-wire connection to the boiler. We need to deal with the pump. So right off the bat, we've got a primary pump, and we're gonna leave it to Dave to come up with what he thinks is the best pump for this scenario. The reality is it's a pretty low flow, pretty low head. There's some pretty obvious selections, and Dave, I'm gonna pass it over to you to talk about it.
All righty, thanks, Mike. And hey, while you're passing it over to me now, if you can give me the keyboard and mouse, we forgot to do that before, remember? So anyway, so we chose the 0015E3 for one, for it like Mike says, it's an easy, simple circulator that you have out there. But a bunch of the things, if you're not familiar with them, it's what we're used to, right? We're so used to these things as a 3-speed circulator where you had low, medium, and high settings. But now what you've got is a circulator that's got low, medium, and high again, but it's a 3-setting circulator, not just a 3-speed circulator. And you guys are going to get a copy of all this stuff tomorrow too at the same time. So I'm not going to read everything off of here, but I do want to point out a couple of the really neat features that you've got. One is going to be that universal flange set. And if you take a look in my camera, you'll see it. I've got a circulator here. So that universal flange, so when you're going to any replacement projects and you don't know where the circulator is positioned, you've got that all set up for you there. And then you've got machined nut grabbers on the other side. So it only takes one wrench to tighten these things up. So it makes it a lot easier to install. What does double insulated mean that I see there? Well, the motor, when you look at an ECM circulator here, the motor is this black part that you see here. The green is actually just a circuit board and an air pocket and to hold our wiring. So the motor is injection molded. And what we mean by double insulated is that there is no ground screw when you look in the electrical box. You don't need to ground this circulator. There's no way for stray voltage to hurt anybody or anything out there. So you don't have to ground it. So that's what the double insulated means on there. Much quiet circulator nowadays, maximum 44 watts. All right, this goes up to 18 foot ahead, out to 16 gallons a minute, and stuff. So let's see, do I got control?
You do.
All right, I don't see it. Oh, okay, let's see, it's just lagging a little. I'm not gonna click on it too fast. So anyways, one of the biggest things I want to talk about too that it has on the bottom, you see that last line, it says biobarrier. Biobarrier is a it's not a filter, it's a barrier. And what it's doing is going to make sure any contaminants that are in the system, mostly any ferrous components, any steel components. Looks like we jumped 2 slides, right? Let's try and go back. I think I might have clicked a couple of times. Yeah, we jumped a little far ahead, Mike, didn't we?
You did.
Okay.
Hey, it's better you than me, man.
There we go. All right, there we go.
The joys of
So
the internet.
the biobarrier is because an ECM circulator internally has a magnet in there, and of course any ferrite components, any what we call black iron oxide that's floating around in the water, we don't want it to get there. There's a very, very small amount of water that's inside a circulator. Okay, very small amount that's inside, about a teaspoon or 2. And what we want is any of that water that comes into that cartridge area, we don't want it to have any of that bio in there, that black iron oxide. So that's what the barrier is. And I bring it up because what I also want to make sure that everybody is familiar with, if you're using this circulator for a replacement in an existing project, I have heard way too many times that, oh, I'm putting ECM in, I must put a magnetic dirt separator in. They're a good idea, all right, to do, but on an existing project, I don't want you to add more dollars to a project because you're putting in an ECM circulator, all right? Now, another thing that these ECM circulators have that we've built into all of them is our Sure Start. Sure Start's an automatic correction feature that we have. And what that's going to do is make sure this circulator is going to last a long life. And you see it's got some LEDs in the front side of it. And I want to be able to show you what Sure Start is. There's 2 features to Sure Start, an air purge and a locked rotor, and it tries to automatically fix itself. So I've got a circulator right here. I've got a 15E3 circ. I took the casing off so you can see the impeller. If I pull this out, you'll see that bio barrier, see that brass ring on the inside there. I've corded this one and I threw a switch on the front side. So if I turn this thing on, obviously we're airbound, right? I mean, I don't have a casing on the back here. There's no pipe. So we're airbound. Now what you're going to see here is the orange operation light on the front side, okay? And then when you see that flash to white, that means I know it's airbound, and what it's doing is dropping its speed real fast to try to push the air out of the circulator. It's not purging your system. It's just getting any air that might be locked into the circulator, into the casing there behind the check valve, so it doesn't burn out the circulator. All right, this is going to happen indefinitely. It's going to keep on running. So what I can feel is that when that white light flashes on me, I can feel it drop its speed really fast. Again, you can't make it happen. This does it all on its own. I can make it happen because I'm running it dry like this right now. The other half is the seized motor, all right, when the impeller's not spinning. And usually that happens in the beginning of the fall, right, when these systems are sitting all summer long, not moving at all. And I'm going to hold this impeller in place and turn it on. And it's going to try to run. And it's not. And actually, the light configuration will be a little bit different. I'll get a red and then a flash to white. So what that means is it stops, it shakes itself violently back and forth, and then goes up to full speed, 5,000 RPM, over speeds than what the speed of the circulator normally would do, to try to break itself free. This is going to happen about 100 times in 20 minutes. If it doesn't, then it stops. All right, red light, and it says, come fix me, figure out why, because I don't want to burn out. In order to reset it, you just go ahead and cycle power to it. So you could probably hear it running too. Here's the shake part. And now it goes up to full speed.
That questioning look on your face of can we hear it is fantastic, Dave.
So that's all built into the circulator. So it's and I see a question from Khalid. No, you don't need to clean it. All right, you don't need to take it apart. You don't need to get to it at all. It's just to prevent that ounces of water when it goes through, to make sure there's no fine materials getting in there. It just, whatever's in the water just stays and keeps on going past. So another question came in from Jordan. Do all newer ECM circulators need to have the head spun depending upon orientation? Any circulator for that matter we always want to see the motor horizontal. All right, so if you're pumping this way, as in we're going up, we want to see a horizontal motor. If you're pumping, perpendicular or parallel to the ground, all right, motor horizontal. I don't like motors sitting up. I don't like motors pointing down. All right, so, but you can easily take the 4 bolts out, all right, and rotate this to any configuration like I did here. Normally this comes in this position, all right, as you can see. All right, but you can just take it out and you can take those 4 bolts out. What I want you to do when you do that, take those 4 nuts out of there. Do not separate the 2. There's an O-ring that's in there, and it's a tight seal. The motor's going to stay in place, so you don't have to worry about that. And just grab it and twist it to where you want it and put the bolts back in. The only thing we don't like, we show you in the instruction manual, is this way. We don't like electrical box down low. That doesn't mean it's not going to work. We just like the old adage, electric above water. Okay, so
and the big takeaway from what Dave, the big takeaway from what Dave is saying is do not take it apart. We've had guys who've taken it apart. Once you take those bolts out, you want to rotate it while it's still in place. You damage that inside gasket, you're going to regret it. So you don't want to do that.
Right, correct. Yep. All right. 1 click. Let's see what happens. So a little bit of new tech that Mike and I are using too, that we can both do the same PowerPoint, which is nice. So it's going to be fun this way, I think, instead of just listening to one guy talk for the whole hour or so. All right, let's see here. Harvey, any idea if the motor only will be available as a replacement part? No, we haven't done that, because the case, the cast iron is probably the least expensive component that we have. So we'll leave the cast iron in place, or just swap it out that way if you want to. Does the pump have periodic run during the no heating season? No, not built into the circulator itself. I'm not sure if they're built into any of the controls that we're talking about, but standard wired controls do have that built in. Our SR and ZVC controls do have that built in. So to talk about this circulator now, looking at the design that Mike had, we had a very low flow, very low head to this. Well, we had a high flow, 7 gallons a minute, but low head at about 5 foot ahead there. All right, so green dot that we see there on the screen is our design point, and we're going to set this circulator in the low speed. All right, it doesn't need anything more. Having it run faster doesn't do anything for us except for use more electricity and actually over pump the system. So what you see there, the green line that we drew there, is the system curve. And a system curve is unique to every project. It starts off at 0, 0 all the way down here, and it's got to go through our point. And the reason why I continued it through is if you were to set this circulator on high, as we like to call contractor no callback speed, all right, because that's what every 3-speed circulator is always set to, it would operate out here at over 8 gallons a minute. The boiler said we only want to run 7, and that's where we're going to get the most efficiency. Now we start to short cycle when we start to over pump the system. It's going to run way out here. You're using up to 44 watts of power now instead of down here where we're probably running around 30, 28, 30 watts, which is beautiful with this thing. So set it up to where it's going to be. You do the designs. Mike's got the numbers there, and he says, all right, set that circulator to that speed. It comes default out of the box on high. Doesn't mean you have to use it on high.
Yeah, I think the big distinction there too, Dave, is that at the end of the day, if you have it on low or medium, a modern boiler is going to see what's happening in that primary circuit that we're showing right now, and it's going to compensate for that, right? It's going to regulate its burner to try to achieve whatever delta T we've told it we want to maintain. You know, it is that distinction we talk about between running and working properly. So, you know, you leave it in medium, you leave it in high, is it still going to work? Are you going to get a call back? Probably not if it's a 0015. Now, if that had been a 0026, completely different conversation. You know, you do want to have some sort of selection happening there. The other thing that's really cool about this particular pump, and I will point out, I drew the mechanical before we even started talking about the pumps. Dave saw this after. And that's a testament to Taco's design on these pumps. When they say what the application for the pump is, you're finding in the design I drew that it actually does work for it. So the big thing with that 0015 pump is what happens if a big portion of our load shuts off? Well, the nice part is with that 0015 pump, it's going to continue to work. What's going to end up happening is we have had a change in flow. So our flow is dynamic, but the head is pretty much, you know, as you can see here, right? So we're still on the exact same spot where Dave wanted it. We've just shifted down to where we are now.
So one of the things I want to make sure that everybody knows about this circulator, when we call it, it's not a 3-speed circulator, it's a 3-setting circulator. So there's going to be a lot of speeds this thing has. When you look at low and medium, those are the variable speed modes of the circulator where it can change speeds, and it works on what we call a constant pressure. So it's going to maintain a 5 foot ahead constant discharge pressure on low. At medium, it runs 10 foot ahead constant discharge pressure. But when you set it on high, it's giving you everything it's got always, just like a traditional AC circulator would be. It's going to give you everything that it needs. And there are instances where we need that to happen, as we'll see as we go through the design of the project tonight.
So we're going to talk a little bit about the air handler and the controls aspect of this now. So we've already talked about the gateway. So the gateway just connects directly to the boiler as identified, simple 2-wire connection. It's using a local area network. I think there was a few questions, but I'll leave it to Dave to bring those up as we go. The air handler in this case is actually the one that you see directly behind me. So this is the IBC air handler. What's really unique and smart about this air handler is it's all set up through Bluetooth. So when you go into this air handler and set up all your fan speeds, they're using Bluetooth, so it's very, very easy. You do it off your phone, very slick to do. So how we're gonna end up controlling the system is we have a wireless thermostat. So you can see the wireless thermostat in the drawing, and I also conveniently have one in my hand. So obviously no wires, battery operated. And what this thermostat is going to do is it's gonna communicate back to the gateway. The piece that you see in the middle that I just made spin around for us so we know what we're talking about is the relay. So what's going to happen here is that when you go to that thermostat and say, okay, it's time to heat, it's going to send the signal back to the gateway, but it's also going to tell the relay, hey, the thermostat is calling for heat. We need to turn this pump on. What's unique about the relay, and I have a loose one in my hand, and we are actually using them for the entire system on the wall behind you, is it is also a power meter. So in this scenario, the thermostat sees the heating call, it closes the relay, and it tells the boiler to turn on. From a diagnostic standpoint, we remotely can see we have a heating call. Yes, the heating call is there. The relay has closed to bring the pump on, and yes, the pump is pulling power. We've closed contact to turn the boiler on, and we can see the boiler is running. So it's very simple, easy to set up, but it's got a lot of smarts under the hood where we can do a lot of diagnosing as technicians when we want to figure out what's happening with it.
So
again, this is the setup and how it looks.
Oh, sorry.
No, go ahead, Dave.
One of the questions came in, is this Zigbee or similar wireless technology from Slobodan?
Yeah, so this is actually using a local area network, and it is Zigbee. So there is actually 3 protocols that are being used. So the Zigbee is the communication that is happening inside of the building. There is Ethernet to get you out of the building, and there is Wi-Fi to also get you out of the building. Again, most mechanical rooms we've been in don't have an Ethernet wire hanging around that you can just plug a gateway in. So the Wi-Fi is really important from that. The really key thing here is that as the contractor, you take your phone and you connect directly to the gateway like I showed you in the slides before. You do not need their Wi-Fi. They don't even have to have internet for you to set this system up. It is very simple, no internet required. So all this is showing is basically the flow path. So what's happening is the VX boiler is connected by 2-wire to the gateway. The relay is in turn paired back to the gateway. The thermostat's paired back to the gateway, and it's turning our pump on and off. On the right-hand side, you can see I'm connected through my thermostat. And at that point, all I'm going to do is push a button to say I'd like to add a new zone to the system. So as soon as I click on that button, I'm actually going to be posed with, okay, what am I going to call this zone? And it's just plain simple English. So I could say I'm going to call this the bedroom, or I could go for an actual custom name and say, this is Dave's office. And as soon as I do that, it's going to have the zone fully set up. And from there, I just have to pair the devices. What's really cool about this is as soon as you connect the gateway to the boiler using the non-polarity sensitive 2-wire, all you need to do is push a button on the back of the thermostat, button on the back of the relay, and button on the actual actuator itself, and it automatically knows that it's going into the zone that we just called Dave's room. And again, because it's using Zigbee, we don't have the requirement for, oh, there's no internet here. We have to come back when they got the internet, and then we'll get their password and we'll set it all up. It's using a local network to achieve that. So the other thing that's important to note here is that although we are using a relay, with these pumps, the relay is an optional thing. This ECM pump, you are more than capable of running it at no flow. The nice part about using the relay in this configuration is we do have the on-off control, and more importantly, we have that power metering function. There is no requirement to run new wires here. This relay controls what we call a man-in-the-middle control. So rather than running the power directly to the pump, the power goes to the relay, from the relay to the pump, and that completes the power to the pump or whatever we're controlling. It could be we're controlling the air handler. It could be we're controlling something that's not even part of this mechanical design. So from there, we're going to hand it back to Dave to sort of talk about the best pump selection we can have here. So in this case, we're again doing one of the ECM circulators, but in this case, it's going to be controlling the air handler.
Excellent. Thank you, Mike. So a couple questions came in. I saw one on the 0015. Does it come in different horsepower? No, the 0015E3 standard circulator size. That's when we get into the 0026 if you need something more. The 0026 means up to 26 foot ahead out to, I believe, 48 gallons a minute. So different size circulator right there. So
or bigger. We could even get into the VRs, right, Dave?
Yes. Yeah, we go all the way up to 275 gallons a minute with some ECM circulators. Just not gonna be able to cover off on those tonight. So right now the 15E3 for the air handler was going to be set on a different setting. It was going to be a little bit higher on there because we had an excessive amount of pressure drop due to the length of pipe to get there and the elbows and the fittings that you don't see on the drawing that Mike actually had drawn into his or had used into his calculations. The drawing doesn't show it there. So we end up with a high head loss. So this is where the circulator would be used in high because otherwise we would be operating at a much lower gallons per minute when you follow your system curve down. And if you set it at medium, we'd be at 3 gallons a minute where we need to actually have 4 gallons a minute to the system. If you had it at low, you'd be given about 2 gallons and only half the flow out to the unit itself. So that's where the versatility is now coming into with this 15E3. One, make it variable speed, or two, make sure you've got it operating at that high flow rate that you need and high head out to the system itself. All right, let's see where we're at. There we go. And let's get rid of that and go to the next slide. And we've had a couple of questions coming in there. Have the smart pumps had any issues going back to the initial run settings after a power interruption? No, not at all, especially not with the 15E3 here. The 15E3 it's a dial. So nothing's going to change settings if you power down. And remember, we want to power down, our circulators anyway. I like to shut them down anyhow. What's the most efficient circulator out there? The one that uses no power, right? So shut them down, it turns back on again. It's going to keep its settings on what's going on there. Now, we also talked about swapping out that 15 circulator and putting the 18 in there. And the reason for choosing the 18 to go into this is it has very similar operations, meaning performance, max performance like the 15 does, actually identical. But now the 18 circulator, what that has is a Bluetooth chip built in, and we've got its own app where you can now, the term that I like to use when I first used this circulator was see inside the pipe. So the designs that we put together are always great, right? You got the math, you got the numbers. Then we go and install the whole thing. We purge it, we fill it with water, we wire it all up, we turn it on and pray. We pray that it's going to do what it's supposed to do. When you use the 18 here, the app is going to tell you what the flow and head is going to be in the system now. And we have a lot more flexibility and really fine tune that system in there now too. So, so now we've got a couple more options on settings the circulator up. We have what we call active adapt for your TRV proportional pressure style systems out there. We've got now 9 different curves on your constant discharge pressure, so you can really get close to your design if need be. And you set it up with your device. All right, it can be your phone, it could be your iPad, whatever you have communicating to it. So different than the controls that Mike's talking about, this is at its own Bluetooth built in. Again, still has the same sure start and bio barrier, just like we had with the 15, the 4-way universal flange. So here you can see the 4 different modes of operation. The orange that you see here in the middle is that constant pressure mode. That's your zone valve mode. And now we've got 9 different curves to choose from instead of the 2 that the 15 had. Okay. And if you didn't want to use the app, you have the dial to do it. So we have it listed as ZV, medium and high setting. All right. So that's your zone valves. That's your proportional pressure orange mode. All right. The 9 proportional curves over here in the green mode is if you had TRVs there. The fixed speed, where you dial it in from 1% to 100% speed of the circulator, is your zone circulator. That would be good, say, for this air handler here, because you might have to run it at full 100%. We don't want it to become variable speed. And then the active adapt, the auto mode. And basically what auto mode is going to do for you here, the active adapt, is going to say, all right, which one of these curves do you want me to operate on? It's going to figure it out for you. So, but it's only available through the Bluetooth mode. You can't do that from the dial. Okay, so those are the 4 different options that you have for the circulator itself. And like Mike was saying, you know, based upon our design with the high head and high flow, you could use the 15, or we could have gone away with the 18 and set it on high. But now, at least when you do that, you can see what the flow and head is. In the app itself, it has at the bottom of the screen your flow and head when you are communicating with the circulator itself.
Yeah, so the 0018.
Go ahead.
The 0018 and a new installation, like in the job that we've drawn it up, the 0018 wouldn't necessarily be the pump that I would gravitate to. But the reality is the bulk of what we're doing is retrofit. So if you're faced with a situation where, you know, again, there's an air handler installed in a building, you have no idea what that piping looks like, you know, how many 90s or what they've got hidden in the walls that aren't there. That's where the 0018 really helps you. You can put it in a Bluetooth mode and you can really tweak it, whereas with the 0015, we're missing that. So if it's a new installation and you know you got 50 feet of 3/4 inch on it, 0015, you can do the pressure drop. When you're not knowing, the 0018 really shines. It's a small premium for the pump, but it gets that distinction of what we talked about where you know that 0018 isn't just running, it's working right. You can verify it and you can validate it through the reporting that's inside that 0018 pump.
So one of the questions that came in was about the Bluetooth. All right, so there's a little bit of confusion because we had communication Bluetooth with the control side, and then we have communication Bluetooth with the circulator. They are 2 different animals right now. So Mike has a Bluetooth communication with his gateway for the system that's going to be able to communicate with everything out there. The Bluetooth that's in the 18E is independent of that. These are 2 totally different things. They're isolated. So you would communicate Bluetooth wise to the circulator and that's it. And then you set it up. Then the other Bluetooth is to set up the control side of things, not the circulator. So it is 2 separate steps that you have to do there. Hopefully that clarifies some things for you all.
Yeah, and I think we can probably articulate it a little bit in the next slide as well. So again, we're going to talk a little bit about the radiant zones, but before we do, let's just roll back. So again, this gateway right here doesn't actually use any Bluetooth, it uses Zigbee. So this Zigbee gateway is going to get its signal from the wireless Zigbee thermostat, which can be located anywhere in the building. It's going to send the signal to the relay to say, hey, let's turn this pump on. But the pump itself, in the case of the 0018, Dave has set that up by connecting directly to that pump. It doesn't have anything to do with the actual controls to it. The same can be said for IBC's Bluetooth air handler that, again, you can see behind me. You're going to take your phone out, you're going to connect directly to it, pardon me, Wi-Fi air handler, you're going to connect to it, and you're going to set those fan speeds. It's completely separate to it. Really, the big takeaway from this is just understanding that there's a lot of smart controls out there that you can set up very easily with a cell phone or an iPad or whatever the case may be, and it allows you to set up a smarter, more efficient, better system for the end user without having to think too hard about it. So then the other thing we're going to talk about on this drawing is our radiant zones. So on the right-hand side, you can see we've got 3 zones of radiant. And in this case, we actually have actuators. So there is a wireless actuator inline feeding each of these. We're just going to point out to you that this is using, in this case, a Rayhow Pro Bounce manifold. The reason we're using the Pro Bounce is because under CSA B214, you must provide a manifold where you can balance and validate your flow. The reality is we should have been doing it anyways. Now with the changes to CSA, it's not an option of whether you do it, it's a requirement that you're going to do it. As far as the wireless Zigbee setup goes, it's exactly the same, right? We have our gateway that's connected to the boiler by 2-wire. That's the only wire that's happening here. We have the wireless relay that's controlling the pump. We have the actuator that opens when the thermostat calls, and it's very simple from that standpoint. And again, we name our zone whatever we'd like our zone to be named. And then once that zone is set up, we push the pairing buttons on all the devices. They automatically pair into that zone. In this case, we'd say it's Mike's Boiler Lab at Eden. With a simple button push, every single one of these devices automatically plug into that zone. As far as the pump goes, so this pump's a little bit different because in this case, we've got zone valves all over it. So Dave is going to have a couple of different options that he may want to look at from the standpoint of which of these pumps is the best choice to handle that.
Excellent. All right, so yeah, so with a zone valve application, we want to have obviously variable speediness of the circulator, right? So we want it to speed up and down as valves are opening and closing, and it does it internally. There are no sensors in order to change the speeds. And actually, when you look on the inside of this thing, it doesn't even have any, you know, there's nothing there. There's nothing inside this circulator to say that it's reading pressure or anything like that, because they don't read pressure. How these things speed up and down, it's an algorithm that's built in there. It looks at an amp draw and an RPM of the circulator, and it's going to speed up and slow down based upon the demands of the system itself as valves are opening and closing. It's basically the availability of how much water it can flow. How many holes are open is how much water it's going to send out to the system itself. And it's going to bop back and forth across the flats that you have here. You know, the medium setting, if you're in the 18 and you set it on high, you're going to be way up here at 15 foot ahead. You set it at medium, you're at 10 foot ahead. When you get into the app itself on the Bluetooth setting, then you have all these extra curves, and you can choose the different curves by choosing the arrows at the top here, or you just tap on which curve you want it to run on. Based upon your flow and head calculations that you have. Find your highest head in the system and choose that one there. And you have, you know, so you can use the Bluetooth if you want to, or you can just go straight out to the dial and set it up as you see fit.
Yeah, definitely the dial is the way to do it though on that pump. Like the ability to really dial it in, good choice of words, I'm sure. Bluetooth really is the way you want to be setting that pump up. I don't see any reason why you'd want to be setting it up with the dial, unless you're out there and you don't have your phone, you've got the fail-safe. I can still set this pump up, but really going into Bluetooth and having those extra layers, especially in this particular application where Dave's putting the 0018 in, and I've slapped the whole whack of zone valves on it. So,
right. Now, another option that we can go with for circulator selection when it comes to a radiant floor system is a little bit different. All right, and I would personally go towards the VT2218. All right, actually, this is your slide, Mike, not mine.
Yeah, well, I mean, you're addressing it, right? At the end of the day, let's just look at this again from a retrofit application. You know, you've got a job, you've put the boiler in, the piping is a mess. You think you fixed it, but you've got these 3 radiant manifolds that you're not really sure what you've got out there. You know, you can figure out roughly how many gallons a minute you need, but There's also ways to roughly figure out how many feet ahead you got out there. But the easier way to do it is where Dave was leading, is we know that with a radiant floor system, we're either designing it around a 20-degree delta T or a 10-degree delta T. There is a product that can do it. And we in particular are huge fans of this VT pump. And that's the pump that Dave's going to cover now, which is the VT 2218.
So bigger circulator, 22 foot ahead, 18 gallons a minute, ECM, different design to it. This one has a delta T operation, whereas the 15 and the 18 have a delta P, pressure differential operation on how it speeds up and down. This one is going to use external sensors, and they just wire right to the head of the circulator. As you see here, right at the bottom, there's two sensors. There's strap-on sensors, one on the supply, one on the return of the radiant, and the circulator is going to speed up and down. It's defaulted to a 20-degree delta out of the box, but it's adjustable between 5 and 50 degrees. So, and then you can change a whole bunch of other settings if you want to. You can do a fixed speed circulator. You got a 4-speed circulator now, because what's better than a 3-speed? One more, right? So now you got to fix a 4-speed circulator. You can do set point heating. All right, set point heating, where it's going to maintain a temperature at that sensor. And what's cool with that, all right, here's a fun thing to do with it. All right, and we've got fan coils, right? Mike's got a design of a fan coil in here. But homeowners, when they have a fan coil in their house, what's the biggest complaint a homeowner has when it comes to a wet coil installed in their house? Every once in a while, they feel cool air, then it warms up, right? The air temperature can change. So what you can do in set point mode with a circulator going to a fan coil is you take that temperature sensor, don't put it on the pipe, you put it in the airstream, because if you notice, set point heat goes up to 220 degrees. So you put it to a nice warm air temperature setting, and that circ is going to speed up and down to maintain a nice fixed air temperature coming out. All right, so that's pretty cool. We do some cooling with it. So if you had some geothermal systems, you could do with chilled water. And if you wanted to full speed it, you can easily just hit the up arrow for 3 seconds, goes into full speed rather than be variable speed at all. And nice little digital display to show you everything that's going on. It'll tell you what mode it's in. It's going to do the calculation of what the actual differential is at the moment, the watt draw that it's pulling, the gallons per minute. Now again, the gallons per minute, it's not a flow meter, it's an estimation. It's plus or minus 5% or so, and it will give you the current supply and return temperature readings that it's operating in. And you can flick, you can change it also from to metric if need be. And get rid of the Fahrenheit and gallons per minute. You can swap it all over for you, built into the circulator. So very, very easy circulator. One of the best circulators out there, I feel, in controlling a hydronic system. And I have this in my house, controlling my radiant floor with actuators. And I have another one that's just a zone circulator, but it is speeding up and down as the temperature changes even outside. So really doing and making sure it gives me that 10-degree delta, or actually I have mine set up as a 15-degree delta, and really even out the temperatures throughout the house. Really makes a radiant system do what it's supposed to do. And radiant is not designed from the homeowner standpoint to heat their house. What do homeowners want? They want warm floors, right? And the more you can modulate that water temperature going out to the floor and the speed of the water, the more comfortable it's going to feel. And you can fix a lot of systems out there with a good circulation going on there, with good control.
Yeah, if you look at all the pumps we've talked about so far, all of them are great pumps. The 0015 would be the good, the 018 would be better, the VT in my view would be the best. If you put a VT pump into a system, you can really dial that in. You're going to pay a little bit more than you would for a 0018, but you're guaranteed performance. It really is, from a residential circulator standpoint, probably one of the best pumps that TIG was made.
So here you can see the curves that you have out there. So in the delta T mode, it's going to operate anywhere between A and B. So it's going to really find what you need it to do. If I were to say any circulator, I'm not a fan of that term smart pumps. All right. A lot of people say, oh, they call them smart pumps because it'll do the thinking for you. No. Right. That's what we get paid to do, you don't want to walk into a customer's house and say, well, I'm going to put this in your house so I don't have to think. No, that's our job. That's what we're supposed to do, right? So none of these circulators, as we saw today, is going to do that work for you. The delta T mode gets kind of close. you still got to make sure it's going to be the right circulator, right? If you like to do zone pumps, may not be the best circulator for you because we live in a very low flow design world, and it may never come off a speed A, which is running at 9 watts, which if you want a 9-watt circulator, that's not a bad choice. All right. But if it doesn't have anything to speed up and down to, then maybe it wasn't a great choice for the application. And here you can see it in use on that radiant floor. We do a radiant supply, we do a radiant return with that delta T going out to your radiant floor with or without actuators. You could have actuators on there or not, you're good to go. But we also wanted to show you want to do some more modulation and make a radiant system even better, is throwing in a modulating mixing valve. Now, those of you that have worked on radiant systems and you see fixed point thermostatic mix valves out there, right? And homeowners, it's all over the place, you know, control wise, is because of that fixed temperature. It could be too hot one day and too cold. I mean, just look at the last 2 weeks alone and what's been going on, 3 weeks alone with temperature outside for heating, right? All of a sudden the heat's on and then it bangs out there, gets really warm out and the house gets really hot because it just, the thermostatic mixing valve just said, hey, we're going to send everything we can. Well, the I valve, we have a thing that we call the I valve. The I valve is a modulating mixing valve. All you need to do is send 24-volt power to it. 24-volt power, it's going to have a supply sensor and it has an outdoor sensor, and you can throw on an optional boiler sensor if you had a cast iron boiler here, and this will give its own reset curve and modulate the water temperature going out to the radiant system. Really changes the way a radiant system operates. And if you have a standard thermostatic mix valve installed with unions, it'll fit in the exact same spot too. So really simple install to get that going and change the whole dynamic of a radiant system.
Yeah, where this really shines too, Dave, and even in our design that we had, is that a lot of homes will, you know, especially even my own home, I've got a lot of glass. So there's sections of my house that are completely different temperature zones than other sections. So in our drawing where we had that I series on the radiant floor and we had that air handler, it's for a reason. There could be areas that just simply don't need that. And this I series valve is really ingenious from that standpoint. Yes, it's going to be more money, but at the end of the day, we're selling comfort, right? We want to make sure that they are comfortable, and to have a little bit more premium on a valve and deliver that comfort and deliver that efficiency. You know, it really does come down to, you can pay me now or you can pay me later. You know, if we can maximize the efficiency of the system, it's going to make a world of difference, and you're going to be more comfortable.
So a question came in from Matt, was asking about the concerns of a mixing valve with outdoor reset and a boiler that had outdoor reset. Not at all, because what you've got going on with when the mixing valve by itself is now looking at load reset. It sees what that load needs. All right, for temperature wise, and with the variable speed circulator, the circulator knows how many BTUs are just leaving that zone. Boiler reset doesn't know typically, you know, in the entire load, you know, it doesn't know the load that's being used. It just knows the boiler reset. It's got its own outdoor sensor on there. Now, the boiler that Mike was talking about before does see the load changes out there. And if it needed to, the valve would just go to full 100% open. If the boiler was firing that low, then whatever comes out of the boiler is going to go out to the radiant. So they don't fight each other whatsoever. When I look at the two of them combined, then we get full system reset. That really makes a really nice combination. And I have that in my house. I've got modulating boilers, I've got the modulating mix valves, and I do have obviously the modulating circulators, and everything is just beautiful here in my house.
Perfect. So the next unit we're going to look at that Dave and I think is pretty cool is what's called a gradient furnace. So this is a pretty cool new unit. Obviously, I'm a big fan because it's Canadian made. Dave's going to go raw Canada, at least for the purposes of this webinar. So what's cool about this unit is it's a combination unit. So it's made in Canada, as identified. So it is a furnace and a tankless integrated in one. Even cooler, and it's going to be the example that Dave and I go through, is it's actually a furnace and a boiler integrated into one. So really where this is quite appealing is a house like my house. So I've got a Lennox SLP furnace in my house, and I'm faced with, do I put a boiler and an air handler in, or do I just slide that furnace out, slide a gradient furnace in, and while I'm doing it, I'll rip my water heater out, and now I've got one packaged unit that's taking care of both. So it's a nice, simple packaged unit. It's actually less money than doing an air handler and a boiler, and it fits into a smaller footprint. So one chimney, one gas line. I'll harp on the Canadian made. It's a pretty cool little premise that we're seeing more and more of. So as far as the piping of this one, it's similar premise. We've got an indirect that's opting out on this. This design is a little bit different. So in this case, the air handler was designed to run at the exact same temperature as the floor. So when the air handler was sized and it was designed, it was let's oversize that air handler. Let's try to future-proof our design, because down the road, it may not be a gradient furnace, it might be a heat pump. So let's make sure when a heat pump goes in, that coil is still going to be able to heat the space. The other thing that's different here is that the air handler is controlled by a thermostat. The actual radiant floor zones that are on the right-hand side are controlled by sensors. So we'll say the homeowner in this case said, I physically do not want to see any thermostats. I want little sensors that are less obtrusive. We have zone valves everywhere instead of doing individual pumping. So at this point, we have a need for one pump, one variable speed pump to meet the need. And I'm pretty sure that Dave has a solution. I've got it sitting right in front of me.
No, not at all. It's the next circulator is just gonna operate all on PFM, right? Pure effing magic. So the 0026E, much bigger circulator, as you can see in the picture here, bigger stature, obviously higher head, 26 foot ahead, going out to 48 gallons a minute, if I remember correctly. But it has everything that I showed you before as in the 0015. So this actually just came out new this year, and we do also offer this in a stainless model. So if you need any open systems or you need a stainless model, we do have that available too. Same knuck, it doesn't have the universal flange set, so that we don't have on here. Typically in the larger circulators, we find that's not too much. This is already has the rotated flange set, and I think every manufacturer out there is going in the same direction with it. One of the neat things with this, if the circulator is, I don't have one myself, so, but if you had the installation and the label was upside down like this, you don't have to take the motor off. This one's a little bit different. You see those 4 screws on the front for the cover. All right, you take those 4 screws out, and this black part of the cover is actually rotatable. So you don't have to take apart anything water-wise in order to get the label to line up where you want it to go. You just take those 4 screws out, and it's on a ribbon cable with enough length on there to just rotate it and fit it up to where you need it to be. So that part is really cool too. So same thing, it's got 3 settings on there, low, medium, and high, but it also has 2 more for you. All right, based on the dial itself. It's going to have the active adapt. All right, so all the way down here to the left, that is the learning proportional pressure TRVs or 3-way bypass valves that you may have in a system itself. We see that a little more on the commercial side than residential. Whoops, went too far. So you see the active adapt curves that are there. But let me come back to a slide. I want to show you one other thing that it has. So you see your low, medium, and high, just like the 15. High is giving you full speed, everything. 16 foot ahead at medium, 8 foot ahead at low. And all the way over here to the right-hand side is a 0 to 10 volt input. So if you had a controller, you had a boiler, you had a building management system that was telling the circulator what speed to run at, then you can turn the dial to 0 to 10, and meaning 10 volts, the circulator runs 100%, 5 volts, the circulator runs 50%, and so on and so forth. All right. So here you can see, I'm going to pull up the curves here in a second. As soon as it comes, we're dogging today a little. The first one you'll see is the active adapt and the different curves. This one, again, it learns which one of these to run on, and it needs to run for like an hour and a half to 3 hours in order for any circulator that has some active or learning capabilities in it is going to find it. Here you can see the 0 to 10 volt. All right, so if you want to match it up to a curve, you'll see 2 volts all the way down at the bottom is basically shutting it off. Just when you get to 2.1, then it starts to ramp up, and you can see the different curves approximates for you. So if you had 55%, it obviously would be just over that just around that 6 volt. There's a 6 volt curve. So, and you'll have a yellow LED when it's operating at that point. So would we set either low, medium, or high and then modulate it with 0 to 10? No, not at all. You put it in 0 to 10. Low, medium, and high is not used at that point, right? So it's out of that setting mode. So you don't need to do that at all. You put it in 0 to 10, and the controller is going to tell it what speed to run at. And then let's see here. So nope, out to 44 gallons a minute. Sorry, not 48. Just couldn't keep that number in my head. Let's see here. Let's go to the next slide. It's going to be here any second. Well, while we're waiting, make sure you guys see the phone number at the bottom of the screen. And if you have any questions, definitely give Mike a call down there at the bottom. Actually, it's been on every slide as we've gone through here tonight. Here you can see the variable speed, the two-way zone valve. So for our application today, we were around 16 foot ahead when it was full running at just over 6 gallons a minute. All right, and it's going to slide back and forth on that curve there. Are we fighting each other, Mike? Possibly.
I hope not.
There we go. So, all right. So that's it for the 26E. Great circulator. Like I said, relatively new for us, but not new because it's a platform that we have as we start building these circulators and getting bigger and bigger with them. We also go out to 0034E if need be. So that one's getting out to 50 gallons a minute, 34 foot ahead. That was a little overkill for this project today, so we decided to leave that one out.
Plus, we were trying to keep it to an hour. There's a lot of other pumps. We've done the 0034Es in a lot of projects for people. We've done even the VRs. We did a really big facility with a bunch of those VR pumps, similar to the VTs and the other pumps we're talking about. What really drew us to designing with the VR pump for our contractor was simplicity. We wanted to be sure that it was a very easy solution for them to put in, because again, there was some dynamics we couldn't be sure of. So if you can pick a pump or pick a circulator that's going to work easily, I'd rather do that than have to guess in the field. So we're going to do one last sort of quick roundup on the wireless zoning here. So again, in this case, we actually are using a power meter again, which you can see below the 0026 that Dave has in this drawing. We're using a thermostat for the actual air handler, but for the zones, we're actually doing just tiny little sensors. Again, wireless, battery operated, because the homeowner, we're going to say in this case, chose that they didn't want to have thermostats. As a point of reference, all of these can do temperature averaging. You could, in fact, have 4 thermostats in one room if you want, all controlling one actuator, one power meter. The system really doesn't care from that standpoint. So again, once they're actually all set up and installed, we've got a little bit of a screenshot here just showing what that experience looks like for the homeowner. So in this case, the 3 thermostats are all showing up under the thermostat view. They can do a lot more than just see what the thermostats are and turn temperatures up and down. All these relays that Dave and I use in this design, they can actually click on the switching button and see, what are these relays doing? How much energy is my boiler using right now? So where Dave says this pump's going to use, 4 watts or 10 watts or whatever the case may be, they can actually validate that. So yes, this system is using that relay to complete the function of running the heating system, but it gives that homeowner that smarts they want where they can see what is my heating system actually consuming from a power standpoint. Lastly, there certainly is some scheduling options as well. So it comes pre-built with quite a few very simple scheduling options, but the homeowner also has the option that should they want, they can go in and make their own custom schedules. What's really nice is that it doesn't require me or Dave on site setting this up. Our responsibility is the gateway. We're going to hook the 2-wire from the gateway to the gradient furnace to the IBC boiler. We're going to push the pairing button on the back of the thermostat, which is going to then connect it into the system. Same way for the relay, same way for the thermostats. The homeowner will then put their Wi-Fi credentials on, set up their schedules. It's designed to be very easy from that standpoint. The other thing that's really interesting about this system is you got to think outside of the box. We've had people come up with creative ways to use these relays that we didn't think about. And Dave and I were talking about this earlier. Every now and then you'll have a boiler go into a house that for some reason they've got electric resistance heat upstairs. Well, the reality is you can do that here. you can take one of these wireless thermostats, run it upstairs, slip it onto the wall for them, and you can use one of the relays. You can see it in the enclosure. I have a loose one in my hand, and it will actually turn that electric floor on and off. So you could tell this thermostat that we would like this radiant floor to run with the hydronic floor that Dave just put in. They can communicate with each other. They can run separately. The relay itself is rated up to 240 volts, 16 amp. So the reality is the sky is the limit as to what you guys can do or not do with this product. It's got a lot of options for you. The other thing that I think is really important about this is that it is designed with the contractor in mind from a diagnostic standpoint. So you have the ability to not just see what the thermostat or the system is doing from the standpoint, are they heating or are they not? You have got the ability to drill down on data for everything that is connected to that system. And I'm going to give you a real world example. We did a job last year with a new builder where we helped them put the system in. They were really happy with it. And then I got a phone call on Saturday. And the phone call I got was that the house was at 30 degrees. And of course, they blamed the smart controls. Well, the beauty of it is that the system has reporting. So we were able to log in. I logged in from home with my laptop and could see something that had happened. I could see that the basement thermostat from the graphing report, somebody came home in the middle of the night, likely after a night on the bar, turned the thermostat all the way up because it was cold and it's a radiant floor. So by the time they woke up in the morning, it was pretty darn hot. But they weren't stupid. They turned the thermostat back to the normal setting. We were able to find that because of the reporting and diagnostics. So with this system, if somebody calls you and says, I don't have heat, you can see things like, is the thermostat responding to temperature changes? Are the thermostat batteries good? It'll tell you they're 80%, they're 0, whatever. You can see things like, is the actuator open or closed? You can see things like, is the relay closed? Is the boiler running? So again, from a service standpoint, you've got the ability to access a lot of data in a graphical interface that really shows you what's going on. The other nice part about the system is, again, as new features get added, it uses OTA updates. So what that means is as new software is built, it gets pushed out to everything out in the field through over the air, which means they always have the latest product. And that's really slick. We've all been there where we put a thermostat on the wall because we're an early adopter, and then they've got a bug. Then you got to drive back, take the thermostat off the wall or whatever the device may be and replace it. The advantage of an over-the-air update is you don't have to do that. The update gets pushed out, everything gets updated automatically. So again, this is an ecosystem. The idea behind it is it all works together. So yeah, the wireless controls have no relationship with the Taco or the Taco product, but the Taco smart pumps work really nicely inside of a smart ecosystem. So the nice part about using a gateway that has Zigbee on it is you start to get into really creative things. The homeowner might decide they want to put some Zigbee switches in. The good news is you have nothing to do with the Zigbee switches because none of us want to be doing it. But the homeowner can add Zigbee switches, they can add motion sensors, as you can see, they can add whatever they want to the system. So you're selling a heating smart control, but the homeowner after the fact has the option to add more controls to it. Dave, you want to wrap us up on the Taco?
Well, before we do that, there was a bunch of questions that came through on the electronics there for you, Mike. So I'm going to read them off to you there. So one of the questions was, where's power for some of the devices? So a lot of it was kind of confusing. Are they battery powered or do you have any wires going to it? Anything getting wired here?
Yeah, perfect. So if you look at the wall behind me, so all of these pumps are using the relay control. So what happens is the power connection goes into the relay control and then goes to the pump. So the relays are what is actually powering that pump. As far as the thermostats go, the thermostats have batteries. I'm just going to pop the back off here so you can have a look. So the thermostats have 4 batteries. And the reason they have 4 batteries is because if there's one thing about wireless technology is it can be a bit of a hog on batteries. So 2 of the batteries are there to power the device, 2 are the batteries to make sure the battery doesn't last a year. So the expected lifespan on the thermostat is about 2 years of battery life. So battery operated, sensors are battery operated, and the actuators actually come in 2 flavors. So this is a battery operated version, and behind me you'll actually see, and I'll just walk over to it, these are 4 powered options. So when you're in a mechanical room where you have access to power, we're not going to put batteries into actuators, but there is the option for batteries because one of the things we didn't talk about is you could put this on a panel rad. So you can see I have a panel rad in the corner. This could go on a panel rad. The sky is the limit as to what you can do from the wireless standpoint. Hopefully that answers it.
I think it did. Yes, that was very good, very good. And then another question that came through a couple of times. Well, what is the distance for the gateway range?
Awesome. So one of the challenges with Wi-Fi is that Wi-Fi gets bad interference. I mean, Dave and I were fighting it earlier when we were doing our demo run through of the webinar. Our Wi-Fi sucked on my end and it sucked on his end. So the nice part about Zigbee is Zigbee 3.0 is a tested technology. And what happens is as you add more devices, it actually becomes a repeating mesh. So if we look at the Takeo pumps behind me, all of them are controlled by relays. And every single one of those relays actually amplifies the signal. You look at a Wi-Fi situation, if I had a Wi-Fi router here and I just connected 100 thermostats and 100 actuators to it, you're going to get congestion. With Zigbee, you don't have that. And in the same token, with Zigbee, you don't have the battery hogging, I'm going to call it, where it really sucks down the battery very, very quickly.
Excellent. That's cool. Let's see, was there, so, and I think you answered the second question, are there boosters available for large projects? No, just put a relay in that becomes a booster, I believe, right?
Yeah, 100%. So the reality is that you're not going to need a booster because the actual devices themselves have boosters built into them. So it doesn't need any kind of a repeater of any kind.
Sweet, sweet, sweet. So wrapping up the Takeo Circs out there, and I do appreciate everybody hanging on with us just a little bit longer as we finalize everything tonight. I know slides are running a little bit slow and stuff like that. So look at your 0015 as one of your major workhorse circulators out there, the 15E3. You're going to use it in a lot of applications, a lot of systems out there. Your 18 gets you a little bit more control over that circulator, set it up for where you want it to be. And then you've got the VT2218, that Delta T circulator to really change the comfort level that you're going to run into. And then the 26E, which is your upgraded 15E3 when you need just that little bit more going out to a project. When we look at circulators out there, the entire industry, I think, has a tendency to overpump. And there's a lot of overpumping that's going on out there. We want to make sure, hey, I don't want them cold on my watch. But that was what the other guy said, 20 years ago when he installed it. All right. So now we put a little bit more on top. So we got to be careful about how big we go for some of these things. And now we've got circulators that can dial in and do what we need it to do. Don't be afraid. Don't be afraid. They've been around for a long time. Here in North America, we've been doing these variable speed circulators for the past 8, 9, 10 years or so. With the ECM style, we've been doing variable speed for almost 20 years. And over in our counterpart in Italy, this circulators have been used for the last 20 years also. So you're not getting anything with a serial number 001 on it. We beat the heck out of them, and they've been around for a while. Don't be afraid.
Perfect. Well, the slide says questions. So Dave, I'm going to take over asking questions. So right off the bat, we've got Khalid just looking for clarification on the double insulated. Give us the 10 words or less reminder of what you meant when you said the pump was double insulated.
No ground screw needed. All right. The wire, the motor itself is injection molded, so no way for stray voltage to escape.
Perfect. Cam is asking with the gateway, what is the gateway communication range? It's in the 100 to 150 feet, but sort of like we talked about before, as you add more devices to the house, it becomes a repeating mesh. So if you think about a radiant application, you've got manifolds all over that house. Every single one of those actuators is acting as a repeater. So the signal, again, is becoming much stronger, not weaker as you do the building. Prince says he's super happy about the two-way flange. That's so cool. I absolutely agree. The other thing we really like about that Dave talked about is, again, it holds the nut for you. You don't need to worry about what's holding on that nut as you're trying to get it on, especially if you're using a rotating flange. It gets super tricky with a rotating flange. Makes life really easy. Jordan is saying, do all the newer ECM circulators need to have the head spun depending on orientation? We talked about that, I think, Jordan, already for you. Again, don't separate the entire circulator. You're going to regret it. When you take it out, you want to spin it with it on tight, just so you don't have any issues with that gasket. Slobodan is asking, does the pump have periodic run during no heating season? So the controls that we have, the relay will actually cycle the pump. Dave, do the pumps, any of the circulators we talked about, have that functionality native to them, built in?
No, we don't, but in our, standard old school hardwiring, it is built into those.
Cool.
So, and I'm sure
Yeah,
being
and the other thing
your
too
programming and
is,
scheduling that you can create, I'm sure something in yours too, right?
yeah, so in ours, it actually does do, the relays will cycle the pump as part of the design. The reality is, slow it down. There's a lot of thermostats that do that too, like the Rayhow traditional wired thermostats. They have that where they'll cycle the pump every 24 hours just to make sure it's in good operation.
Oh, I just realized something. So I completely forgot to talk about it when it comes to ECM circulators. So these variable speed circulator, the new design to these motors, much higher starting torque than the standard AC circulator. If you notice, when you opened up the electrical box, what's missing? There's no big ass capacitor in there anymore. All right, we don't need that capacitor. ECM circulators already have such a high starting torque that and it's past already what we've experienced in the past in our standard AC world. So to have that cycle of the circulator in the off mode, I don't really see it as a need because you have the higher starting torque, and two, you have the sure start feature built in there. So thank you, Sean, for that one too, for reminding me that, yeah.
We hope you're enjoying your glass of wine, Sean. Dave and I are convinced that's what you're doing right now. Slobodan saying, is the wireless technology Zigbee? Correct. So the 0018 that we talked about is Bluetooth. The wireless radiant system we talked about is Zigbee. And the air handler, the IBC air handler we talked about is Wi-Fi for setting up the fan. And then the contractor portal that's built into that VX boiler by IBC and the SL boiler, it's an Ethernet plug. You plug it into the back and you've got remote access to that pretty much anywhere. Chris, I think we answered the range question on the Zigbee. It's pretty significant, and as you add devices, it gets stronger. Prince is asking, does the 0015 come in different horsepowers? I think we addressed that. Not in a 0015, but in different makes it does. John is asking, have the smart pumps had any issues going back to initial run settings after a power interruption? I think we covered that, Dave.
Yep, correct.
Jordan says, are the signals commands from the wireless thermostats slower compared to hardwiring? Great question. So all the battery operated devices are known as what's called a sleepy end device. So until you touch it, all it's doing is just holding on to data, and it will pull basically every 5 minutes just to make sure the temperature is right. But as soon as I touch it, it immediately transmits the data back. So there is no issue with it being slower or faster. It's basically the same as a traditional thermostat would be. And I think, Jordan, I answered the max distance, but if I did a terrible job at it, you know how to get a hold of me, buddy. Call me, email me, text me, send me a smoke signal. Slobodan says, what is the reliability of communication between devices through different wall materials, concrete, ICF, etc.? Slobodan, one of the first prototype sites that we did in Ontario was on an island in Gravenhurst, which is about 3.5 hour drive for us. And when Cody and I, Cody being one of the tech guys here, when we went out there to see this initial prototype site, they had concrete walls that were this thick, then followed by an additional 6 inches of insulation. This was like the ultimate net zero home in the middle of nowhere. We had no issues with communication. And the reason, again, is because you add more devices. And last time I checked, we don't have a lot of radiant floor systems that have a single actuator in the whole house or a single thermostat or a single relay. It amplifies and makes the signal stronger. So could we come up with a scenario? Probably. We haven't seen it yet, knock on wood. Casper is saying, question about the wireless thermostat. Does the thermostat itself require low voltage wiring? Nope, it's completely battery operated. Yeah, it communicates wirelessly. He's saying, or is the battery power an option since the device communicates wirelessly? So when I touch the thermostat and turn the temperature up or down, if there is a relay, an optional relay, it will then turn that pump off, sends the signal to the gateway to say, turn the boiler off, turn the gradient furnace off, turn the heat pump off, turn off whatever it is connected to. The 0018 questions, Dave, you already did a great job answering. Jeff House, the ever comedian, says, running versus working. Where have I heard that before? I'm sure, Jeff, you've heard it many, many times. Not least of which is the legendary John Siegenthaler, who always likes to point out the running versus working properly. That's what happens when Dave and I have smart friends that rub off on us. Here's one for you from Jordan. Dave, is the 0018 and the Takeo Viridian the same circulator?
No, the difference between the Viridian, which was the earlier VR 1816, performance-wise, yes, they're the same. The difference is one has the Bluetooth in there, the other does not. So the 0018E is basically the upgrade to the VR 1816 circulator, which would probably be phased out. So, which I think it slowly is getting phased out already. And but that's performance-wise, that's the difference, is the Bluetooth in there.
Perfect. Good question, Jordan. Khalid is saying, does the pump itself? Yeah, so the VT pump uses temperature sensors. That's how it's running its program, supply and return. There's a lot of really cool things you can do with that. You can use it as an injection pump. You have to be careful using it with an injection pump. Dave pointed out earlier, try not to get into the bottom end of that curve or you're gonna run into some trouble with it. This VT pump is particularly good if you have a small load of snowmelt. And that's one of my favorite things for that pump, where we don't want to crash the system. We don't want the water going out at 128 degrees and coming back at 30. So the nice part about the supply and return sensors is we can really regulate the temperature on that VT. If it's a small enough snowmelt, you're guaranteed we're going to use the VT every day of the week. It's a great pump for that application, as well as the other ones that Dave went through. Aaron has a pretty solid feedback on the VT2218 on the sensors. They're a bit of a challenge to get in and out. Do you have any tips, Dave, on the easy way to get the sensors in and out?
One, yes. So I don't have a circulator here in front of me, but there is an O-ring on that on the cover that you pass the wires through. I pull it out. So you can get it in, because that's just a pain in the neck. There's the pass-through O-ring that the wires go through is really tight to get 4 wires through. The capture nut is just to put on there so the sensors doesn't unplug from the circulator when people bump into it. Because when the sensors drop out, one of the things the circulator does is then run full speed. But the screen flashes when someone, if you walk by and see what's going on with it. So that's my ease on trying to do that wiring with it.
Yeah, so it's not often, Aaron, we need to get them out, but we always let Dave answer first before I say I do exactly what Dave does. Dave might have had a better answer, but we sell a lot of Takeo product, and the reality is occasionally it's just human error where we accidentally pull the sensor out and go, how is this going back in? Dave's answer is my answer. That's what we've done in the very rare occasion where we need to do it. Khalid points out that VT2218 pump would be awesome for solar thermal. Oh, completely agree. I mean, that VT2218 pump, as long as you can stay inside of the curve, you'd be hard pressed to find a scenario where that pump is not a good choice. Really, the only thing you're giving up is a little bit more money, right? It's the good, better, best. 0015 is your good, the 0018 is your better, and the VT2218 is your best. If it's in your budget, the VT is the way to go. But those of you who are skilled and done a lot of work, you're probably not paying the premium for a primary pump to put that in. You'll pick a 0015 and just put it on the right setting. Matthew Reed had a good question that you answered already about outdoor reset. Aaron thinks the air handler is pretty cool. I do too, Aaron. Feel free to stop by anytime and you can check it out in person. Slobodan has a good question for you, Dave. He would like to know, with the 0026 sitting right here in front of me, when he's doing the 0 to 10, does he have to put it in low, medium, or high, or is it just 0 to 10?
You just put it in 0 to 10 mode, yep. And then it takes over from there. The control system runs from there.
Perfect. Casper's got some nice feedback. Thanks, Casper. Jordan would like to know, we have access to this webinar to rewatch it. Yes, so if you go to youtube.com/eatenergyequipment, this will go up. Probably not tomorrow. I'll probably wait a few days before we get it up there, but we don't put everything up there. But I know we've got some CSA training we've done is up there, some heat pump stuff's up there, whole pile of stuff that I've done with John Siegenthaler is up there. There's some items with Robert Bean and Gord Cook, and there's lots of interesting content you can check out. I think we're doing good, Dave. We're near the end.
Sounds like a plan.
Thanks, Jeff. Jeff says we did a good job. Jeff says it's good. It must be good. Sean's reminding us about that starting torque. Thank you, Sean. 4 times the starting torque of a standard AC circ. Again, talking about those ECM pumps. Ooh, I like Rob's question. Are the portals protected from hacks, or would a firewall be required? That is a great question. So the actual gateway itself has a VPN encryption. So to get really, really nerdy with you, it's using a local MQTT protocol. So everything is actually stored on this gateway. So if you do not have internet, it does not matter. This is not a situation where you've got a smart hub. I'm not going to name the brand, but a particular smart hub last year said, hey, we've decided we're now going to charge you to use our free smart hub. And if you want to use our free smart hub starting next month, you have to pay us $15.99 a month, or we're going to shut you off. This gateway is a VPN encrypted connection between you and the gateway, and it does not require any external connection. It's a direct one-to-one connection. And Rob, feel free to call me, buddy, and we can talk more about that. That's a really good, nerdy question. I like it a lot. Matthew says, Takeo makes the absolute best circulators in the world. Thanks for the show, Dave and Mike. Thank you, Matthew, for coming. A whole bunch of thank yous. Appreciate it, guys. And at that point, I think we've done our job, Dave. I've hit the end of the mountain of questions. So if anybody has a question when you wake up tomorrow, by all means, email me. If you have a question for Dave, shoot it my way or email Dave. Either way, we'll talk. Dave and I will come up with some magical method, non-scientific magical method tomorrow to pick a couple of winners. And 2 people are going to get 2 free 0018s courtesy of Takeo. Obviously, we appreciate everybody making the time. Dave and I are always doing this, so definitely check out Takeo on Instagram. Check out Dave Holdorf on LinkedIn and Instagram. And by all means, feel free to follow us as well. Typically, we're doing webinars every month. I think Dave's doing it pretty much every week.
Pretty much so, yeah. I've got webinars, Takeo After Dark and Takeo Tuesdays. We've got stuff going on all the time for you guys out there. So Takeo
Nice.
After Dark, if you haven't heard of that, that's in the evenings at 7 o'clock on Wednesdays. And Takeo Tuesday is actually pretty obvious. It's on Tuesdays, but we do that at noon during the day. So find those on the website.
Cool. Awesome. Dave, I appreciate taking the time to do this with me, and I look forward to doing it again, buddy.
Yeah, thanks for inviting me, man. This was a lot of fun. This was a great time. I enjoyed it. We can, based on this format, you and I can, we have like a whole year's worth already. I can think about already in my mind going on. So
Awesome. All right. Thanks, everybody. Thanks again, buddy.
Enjoy, y'all.